Chapter 3? No. Lesson 1? No. Chapter 1, Lesson 3 of Pre-Calculus. We spent some time in the first two lessons looking at analyzing the functions, and now we want to take a look at the 12 basic functions that we have. And each of these functions does different things and applies to different situations, and throughout the rest of the year we're going to be looking at all of these functions in detail, each one separately, and then how they can apply to real-world phenomena or data that we can gather. So what I'm going to do in this video is, well, first let me introduce you to the 12 basic functions, and here they are. You have the linear function, which we're familiar with, squaring function, which we're familiar with, cubing we haven't really worked with, but you've probably seen it. Square root, we've done a lot with algebraically looking at square roots. We didn't do a lot with graphing those. Natural log, the reciprocal function, 1 over x, exponential function, sine function, cosine, these are trigonometric functions, greatest integer, absolute value, and then the logistic function. So these 12 basic functions really fit a lot of the data and a lot of the natural phenomena that we see in the world. And again, as mathematicians or scientists, or just a way of analyzing or looking at our world around us and how things are related, we get these, or we take these information, we put them in tables, we make scatter plots, and then we want to try to fit one of these functions to the data that we see, or to the scatter plot. And once we do that, we calculate the regression. We can then use that algebraic regression to then make predictions about how things or what things will do in the future. So really that's the basics of this course, what we'll be doing through the rest of the year. So we're going to introduce you to each of these functions. What I'll do is I'm going to go to each function. I'll give you a picture. Well, we'll do linear, then I'll explain as we go. So here's a linear function. F of x is equal to x. So up here you have the basic algebraic expression of the linear function, y equals x, and again with function notation we're going to use f of x is equal to x. So for when we put in the x value, the y value that we get is exactly the same. Now we can then algebraically move this right or left, up or down, reflect it over x, and do all these things that we talked about last year, and we will do this year, but this is called the basic function. And then what we want to do is to, as we look at this function, consider the 10 things that we talked about, the 8 things, but because increasing and decreasing count is 2, and then maximum count at 2, we end up with about 10. We want to then look at this function and analyze it in terms of these 10 things. So if we take a look at the linear function and we look at the domain, we notice that it's all real numbers. We look at the range, that's going to be all real numbers as well. It goes up and down forever. It is continuous. We never have to pick up our pencil when we're drawing it. It's increasing on the entire domain. So from negative infinity all the way up to positive infinity, this linear function is increasing. Symmetry, it's symmetrical to the origin. If you turn it 180 degrees, you're going to get the exact same thing. Or if you put in negative x, you're going to get the opposite of the whole function, making it odd. It is not bounded. It goes up forever and down forever. Because it never turns around, goes from increasing to decreasing or decreasing to increasing, there is no max, there is no minimum. There are no asymptotes for this function. There are no y values that aren't used. There are no vertical asymptotes. There is no restriction in the domain. And then the end behavior, the limit as you go towards negative infinity, as you go this way, the y values go to negative infinity. And the limit as you go to positive infinity, the y values are approaching positive infinity. So this is the analyzed function, linear function, and these are some things that are the characteristics of this function. So what I'm going to do now for the rest of the video is I'm going to take each one of these functions. I'll show you the function. I'll then look at the 10 analyzing things. I'll move those down, but I'm going to do it very quickly, but you want to you want to stop the video, take a look and see if you see how the domain and the range fit with the function, so you get an idea of how the analyzing process goes, and then you want to do that for each function. So the video will run very quickly, but I really want you to stop and take a look at each one separately. So the squaring function is x squared. So if you look at that, the analyzed function, these would be the characteristics of this function, the squaring function. Then if we look at the cubic function, that's f of x is equal to x cubed. And again, this would be the analyze function. The square root function, this is going to have some f of x is equal to x squared. Notice it's not plus or minus. We're not considering both sides. We're just considering the positive one. So this is the square root function. And again, this is how you would analyze it, or what it would look like if you analyzed it. Alright. Notice I put down here in the limit notation, you can either put the limit of f of x, which would indicate the function that is f of x, or if it's equal to y, you wouldn't put y here because that's what's going on the right here. So you'd actually put the function in that you're analyzing in here. So either way, f of x, if it has f of x as its notation, if there's no notation, function notation, f of x or g of x, then you write the function in as you see it. Okay, so that was square root, natural log. Looks like this. And the natural log and the logarithm function are almost identical. The only difference is the base is different, but the analyzed characteristics of it wouldn't change that much from the natural log. And the natural log is actually the one we use more often because it's used in financial formulas. So that's why we have that. Reciprocal. X is in the denominator, so you're going to have restrictions there on your domain. Okay, you have two asymptotes, horizontal and vertical. The exponential function, we looked at this one last year, so these would be the characteristics. And again, this is e to the x because that's the most common, a useful function when we're looking at financial formulas and such. But this e, remember, is just a number, so this could be any number to the x power, any base, the number one, except for the number 1. Okay, the sine function, these are trigonometric. We didn't really get a chance to look at these too much last year, but this is what the sine function looks like. And again, we'll talk about this in depth this year because a lot of pre-calculus works off trigonometry. And notice the end behavior does not exist. We talked about this in class. It's oscillating up and down, so there is no, it doesn't approach a single value. The cosine function is very similar to the sine. In fact, you might even get these mixed up. One thing you might want to cover in your summary is what's the difference between the sine and the cosine functions. Can you figure out what that is? The greatest integer function looks something like this. And these are the values. We won't do a lot with greatest integer, but kind of advertising and the way we price things talks a lot about greatest integer. In other words, if something's $2.99, most people will say it's $2 because 2 is the greatest integer. The 0.99 and all that are fractions. So a lot of times in $2.99, people will round off to $2. Oh, that's $2. I do it all the time. But what is it actually close? It's actually closer to 3. But you'll round it down to 2 because that's the greatest integer that you see is the 2. Interesting. The absolute value function, we spent some time on that last year. So again, this would be the analyzing. And then the logistic function. The logistic function has to do with, we'll talk about that a lot, with the spread of rumors or population growth and those types of things. So those are the 12 basic functions, and you'll need to be able to not necessarily know what they are, but as we go through the year, being able to kind of in your mind get a pictures of what these look like before you graph them. You know, squaring, okay, that's parabola. Cubing, okay, that looks like this. Square root, all right, that's like this. Sine, okay, that's like this. To have that in your mind before you start, just by identifying the function, is really what you really want you to start working on and going forward. So that's it for lesson 1, or lesson 3, excuse me. In the next lesson, we'll look at how we can combine these functions to help us fit data.